Now I am discussing the ray diagrams for in case of concave and convex mirrors. So the image formation by first I will discuss about the image formation by concave mirror. So for drawing the ray diagrams for image formation by concave mirror, first take a scale and draw a straight line of any length. I'm drawing a straight line. It's of any length, and now I'm taking this compass and I'm drawing an arc. Just take just like this. Now obviously, since it's a concave mirror, so this one is the back side or the dash side. Now first of all, the rule is, if I consider this xy be the principal axis and this be the pole of the mirror, now from the pole I must take equal lengths on both sides, which will be the focus. So from the pole I am taking 1 centimeter apart as the focus in this side and 1 centimeter in this side, which is the principal focus, and the radius of curvature, which is which must be double the principal focus, is approximately 2 centimeter. Approximately 2 centimeter on both sides. So I got this as the principal focus and this as the center of curvature. Now the rays which are parallel, the rule is that the rays which are parallel to the principal axis, they in case of concave mirror, they converge through the principal focus. So I am drawing a ray which is parallel to the principal axis. We should be very careful while drawing this, since the rays must be exactly parallel to the principal axis. So the ray parallel to the principal axis should converge from the principal focus. And the second thing is that the ray which passes through the principal focus, or the ray which passes through the center of the curvature, goes undeviated, reflects back undeviated, and the ray which hits the mirror passing through the focal point after reflection moves parallel to the principal focus. So these are the rules. Now applying these rules, the first case I will do is that when the object is at infinity, I will apply the same technique. So I am drawing a straight line. Now I will take an arc of any length and I will draw this arc, which is our concave mirror, and this is the dash side or the back side of the concave mirror. This one is the pole. So from the pole I am considering equal lengths for focus. So if this one is the pole, this one is principal focus on the left side, and at equal distance this one is the principal focus on the right side. Similarly, this one is the radius of curvature on the left and right respectively. So this, if this is f1, this is f2, this is c1, this is c2, the centers of the curvature and the focal points. And this is the pole at the center. Now when the object is at infinity, the rays, we will consider the rays to be parallel rays, or the paraxial rays will hit the mirror surface. So these are the paraxial rays. This is the first paraxial rays hitting the mirror surface and reflecting, the reflected ray passing through the focal point f1. This one is the second paraxial ray hitting the mirror and again passing through the focus. Similarly, I am drawing two paraxial rays below. This is another paraxial ray. So we can see that when the object is at infinity, all the rays are converging at the focal point. So the image will be basically a point image. If and hence we can see such type of examples, such as if we try to focus this image of a sun with the help of a concave mirror. Obviously, since the sun can be considered to be placed at infinity, so you will get the image of the sun almost at the focal point, and it will be almost a point object. Okay, so this one is the example when object is at infinity or at very large distances, so the image will be formed at the focus and it will be very much diminished in size. Next is when the object is placed beyond C1, that is beyond center of the curvature. So when the object is placed beyond C, so first of all the diagram will be like this. If we draw a straight line, I am taking an arc of any length, which is usually the mirror. Center O. Eventually, if you can see that if this is the center, from O I am taking equal focal length on both sides. Okay, so this is f1, this is f2, this is c1, and this is c2. Now object is placed beyond c1. So beyond c1 means let the object be here in this position. I am extending the line bit more. Sorry. Now if this be the object, say AB, then of course this is the dash side or the back side of the mirror. Now as we know that one ray hits the mirror parallel to the principal axis, and it passes through the focus f1, and another ray which passes through the focus f1, reflects back, the reflected ray being parallel to the principal axis. Now the point of intersection of these two rays is where the image is formed. So I am drawing this image, this dashed image, rather, since it's an image, so it will be by dashed nature, as you can see. And this is rather A dash, B dash. The image formed is of course real image. Nature is inverted, and since real images are always inverted, and size is diminished. Diminished size. So the image formed is real, inverted, and the size is diminished when the object is placed beyond C1. Now, next situation is the next position is when the object is placed on the center of curvature C1. So when the object is placed on the center of curvature, it's quite interesting that very careful with the lines. Now if this is as usual the mirror, back sides and pole, now likewise I will take the focal length of equal lengths so this is f1, this is f2, c1 and this c2. Now when the object is placed on the center of curvature, so this is the object placed on the center of curvature, so what will happen that if I draw a line hitting the mirror parallel to the principal axis xy and eventually passing through the focus f1, and the second line passing through the focus, and the reflected ray is parallel to the principal axis. So one must be very careful, the rays must be exactly parallel to the principal axis. Little mistake can differ your result hugely. So the point of intersection of the two rays is this one. So if I draw the dashed lines, you can see that the image formed exactly a dash b dash, and the image exactly formed at c1. So if somebody places an object at the center of the curvature c1, then the image will be real image, of course. Sorry. And the second thing is that the image will be inverted, of course, but the size will be equal. The image size will be equal to the object size. So this is the situation when if I place an object at the center of the curvature, then the image size formed is equal to the object size. Now I am considering a situation where the object is placed between C1 and F1, that is between the focal length and the center of curvature. So if this is the object placed, then following the same procedure, in this case I need to extend the line a bit in order to get the intersection point. Now you see that the image is formed at a position beyond C1, and of course the image size is bigger. So the image formed is real, inverted, and enlarged. So now the next case is that when the object is placed at f1. So I am placing the object just at the principal focus or at the focal point. So if this is f1, I am placing the object AB at f1. So first thing is that if I follow the same procedure, rays are first one is parallel, and of course after reflection it will now in this case, since I am not getting the focal point, so the another option is that I will consider another one ray from point A which is parallel to the principal axis hitting the concave mirror, and the reflected ray passing through the principal focus, and another ray will pass through the center of curvature. And as we know, the ray which passes through the center of curvature has no deviations actually, or we can say that the ray just bounces back 180 degree. So this is another ray, and you can see that since the rays are parallel, so of course the object's image, corresponding image, will form at infinity. So the first one is that the image will be real and of course inverted, but highly enlarged, and will be formed at infinity. Now the next situation is that when the object is placed within the principal focus and pole, object is placed within the principal focus and pole. So now as you can see that I have placed the object AB between the focus f1 and the pole of the mirror, that is at the point O. So I placed the object between the principal focus and the pole of the mirror. So let us see what happens. That one ray of course will be parallel to the principal axis, and surely it will pass through the focus. The second ray, as I've told in the last picture, that it will pass through the center of the curvature like this. Now if I produce this line, two lines backward, that is in the back side of the mirror, they eventually meet at certain point, and of course beyond f2. So this is a dash and b dash, and in this interesting fact is that up till now we obtained the image. So the image formed up till now, it was real, inverted, and enlarged or diminished. But in this case, when the object is placed between the principal focus and the pole, so we see a entirely different scenario. That is, the image formed is actually virtual, and of course enlarged. And surely it's erect. It's not inverted. You can see AB and it's A dash B dash. So this is our four situations or the four positions in case of a concave mirror for the image formation. So as if I repeat the whole thing, that first thing is that when the object is placed at infinity, we see that all the rays converge at the principal focus, or the image is formed basically at principal focus, and the image is highly diminished. The image is real, highly diminished, and formed at the focus. The second situation is when the object is placed beyond C1, the image is real, inverted, diminished in size, and the image is formed between C1 and F1. Next, when the object is placed on the center of curvature C1, the image is real, inverted, equal in size as the object, and the image is formed at C1 only. While when the object is placed between C1 and F1, the image formed is real, inverted, but in this case enlarged, and beyond C1. When the object is placed at F1, so the image is real, inverted, highly enlarged, and the object is formed shearly at infinity because the rays are parallel. And when the object is placed within the principal focus and the pole, the image formed is virtual, enlarged, and erect. Thank you for watching the video. Must subscribe.